Hello, everyone. Welcome on in. We're making a plan today. We've got a plan to improve our deep learning framework that we've built over the past few days. We had a success in the previous stream that we had yesterday. We were successful in implementing our back propagation, which is the hardest part of building with artificial intelligence when building your machine learning framework from scratch, is the back propagation part. The easy part is the forward propagation, which typically is the inference. Echo, hey, how's it going? Echo, welcome on in. We're updating our machine learning framework that we built over the last couple of days, and we got a couple of to-dos here on the screen to simplify, make things cleaner, make some adjustments, and that's the plan for today. We're going to be updating our code to make some adjustments, maybe tuning some of the. We had success. We succeeded in the last stream. It was really fantastic. It was wonderful. Hey, Ashford, how's it going? Welcome on in. Today we're going to be updating our machine learning framework that we built live on stream over the past few days. We were successful yesterday, like Echo was describing, to our back propagation, which, as we saw, we're actually going to use it today. So we want to make some adjustments. And then we want to maybe use the model to do something. Like last stream, we were like, hey, let's use the model to actually do a thing. Maybe we could do that. Well, we want to make a few adjustments first. I want to make a few adjustments that simplify. I added a few right after the stream. I was like, I think there's a few things that we can do to make some adjustments. I think there's just a couple of things. And so we can absolutely do that. So I added a few to-do items here just to make some double checks. And then you can see here that we have some code repetition that we can simplify further. So there's things like this. So we don't need to do like things like this. And then the gradient, same thing with back propagation. Not Owen, hey, welcome on in, Not Owen. We're going to be updating our machine learning framework today, just to make it a little bit easier, a little bit simpler, cleaner, and make some adjustments. And we're going to compare it. This is actually the important part. Check this out. We're going to compare it to what is not like, there's code. All code is code. It's fine. How do you exclude biasness? Wait, what? Wait, how did you exclude? We actually included it. So Ashford, in one of the streams previously, we're going to hold off on bias for a little bit. But you can add in bias in various different ways. So a lot of maybe the textbooks or different models have use of bias that is directly embedded in the model. And that's what we did here. So we have a bias here. Hey, Quantum, welcome on in. Happy to have you here. We're going to be updating our machine learning framework model that we built over the past couple of streams. We're going to make it better. We're just going to make it, a little bit better. That's the plan. A little bit better. And then we'll compare it. Actually, we'll compare it right now. So you can see here on the screen, regardless of like these giant like to-do segments, it's actually pretty easy to read, isn't it? Blue, hey, how's it going? Blue, what is up? LOL, I'm a bit late today. You're actually on 3 minutes. We've only been going for 3 minutes. You're actually pretty good. You're good on time. I can tell you, Quantified Content, we are good on time. Check this out. So it's actually pretty clean. So you can see, a forward pass. Wow. I mean, just look at this. Look, and like this is only necessary. This segment right here is only necessary for training. Like you don't even need this line. If we're going to be building an inference model, we don't need this line right here. That is not necessary. Hey, how's it going? Cryatic. Deep. My grandma drove a U-Haul. All right. I know. Well, where's this going? Where is this going to go? Through one of the Guy Fieri's. Oh, restaurants? Really? Oh, wait. This sounds like a problem. It's like if you drive a U-Haul into a building that causes a catastrophe and some problems, right? After 6 years of appeals all the way to the Supreme Court. Really? Hold on. I don't know where this is going. She finally succeeded in getting the right to death by condensed milk. Oh, okay. I figured as much. I knew where it was going. I was suspicious. I knew it. Graph neural network. Ooh, Emmanuel, that sounds like a really good idea. Some graph neural network. We've got our artificial neural network. The ANN is what we have it here. So we've done an ANN. So this is our ANN, and it's a deep artificial neural network. Because you know what the difference is between deep and a regular artificial neural network is? Do you guys know what the difference is? So no need to eliminate bias. So Ashford, let me. Hey, Hey, Suprita, or Supra Team. Super Team, how's it going? It's good to see you. We were back on it from the previous stream, so I remember you. You've been here many times. Check it out, Super Team. We're going to do, actually, let's update this. Part 3. Let's do increment by 1. There we go. And this will be updating our framework to make it a little bit better, cleaner, simple things like that. But yeah, Ashford, so check this out. You can add bias into your machine learning model in a variety of ways. One, for example, is you can do it directly by manipulating the inputs. So before it gets to the actual neural network or the model itself, you can manipulate the inputs to add a bias into it to help make those adjustments. But this is the common standard ways right here, is to have a dedicated sort of set of weights or parameters here. Some parameters. These are both parameters here. So you've got your biases and your weights. Parameters. They're just numbers. Like this stream, people. Oh yeah, quantify quantum. If you press the heart button, then I can see the little heart icons float up on the screen. I can see a little heart icons float up on the screen when you click the the stream button. Here, check this out. So you got your parameters, and then your weights and biases, which they're just floating point numbers, right? Just floating point numbers. And then over here we've got what do you call it? Your optimize and your backward propagation. And isn't this beautiful? Oh, sorry, I'm marveling. Hey, thank you for the likes, you guys. Appreciate it. And can see all the heart icons show up there. How similar is Perl to Python? Oh, because this is A. How's it going? Letter A. Letter A is here. You're to the beginning of the alphabet. The beginning of the alphabet is here. Letter A, everyone. How similar is Perl to Python? They're very different. So Perl was originated as kind of like a shell script. It's kind of like shell oriented. So sed and awk and bash all kind of have similar syntax, right? And then that's where Perl came in and sort of merged all that together into one big language with a whole bunch of symbols. Perl is a really cool language. I love Perl. It's one of my favorite languages. It's one of my early languages from the day. So we've got early languages on the web. Would be you've got your C++, your C, your Perl, your PHP. Those are fun early web languages. They did really great. Joke's on you. I already liked the stream, Echo. Thank you. Thank you so much. Super Team, actually, in your Discord server, the Fool is me. Oh, the Fool, really? No way. Thank you for the likes, you guys. I didn't know that. So Super Team, the Fool. I'll try to remember, but it's kind of hard. But I'll try to remember the Fool is Super Team. Does it use TensorFlow? Oh, Ashford, no. So the only, thank you for the likes, you guys. The only library that we're using here is NumPy. And Stephen, have you ever read light novels? Wait, what? What do you mean light novels? I'm actually kind of curious about that. So this is the only, hey, Brock, 2202. How's it going, Brock? Good to see you. Welcome back. Brock. This is the only library we're using is NumPy. And we're using NumPy because it makes your code a little bit cleaner for things like this. So you can see here, we've got our inputs times our weights plus the bias. Well, all these things are arrays, right? So you know that this is a one-dimensional array, the bias, and this is a two-dimensional array, the weights. And so what it does is it does operator overloading using dunder methods, the double underscore methods in Python, to override this operator that is able to see two matrices like this, like the weights and the biases, and it can merge them. Together. And the same for the inputs, which is a two-dimensional array as well. So this is a dot product or outer product that then is applied with the bias. And so that allows us to basically represent a for loop right here, but in a single line. And so instead of having to write the for loop ourselves manually, the NumPy does that for us. So it's just doing iteration for us. It does a really good job at iteration. It makes things really clean. So that's why we can have a single line like this with the forward pass. It's so cool. They're like things anime mangas are based off mostly. Thank you for the likes, you guys. Appreciate it. Hey, Juki. Is that Juki? Is that how we say your name? Is that Juki? Juki, Jucci. How's it going? Welcome on in. The things. Have you light novels? Light. So I do remember Light was the name of the protagonist in Death Note, right? In Death Note, Do you remember Death Note? The name of the protagonist was Light. I'm pretty sure his name was Light. That's an anime. It's also manga, and it's related. Quantified Quantum. Though I don't know. I haven't other than that. That's as much as I know when it comes to light novels. That's as much as I know. The org I worked for a lot of Perl. Oh, really? Letter A, a lot of Perl. So Amazon.com was a huge Perl shop for a long time. Amazon.com was a huge Perl shop because they're really close. They're nearby. I live near Amazon, but not many people use it. So we are thinking of rewriting it. Oh, okay. Some people have compared Python to Perl. Thus the question, but a good answer. Thanks a bunch. Happy to help. Super team. Hey, or the fool. Hey, teach me something for my exam. A little bit therapy part. Teach me the architecture of ResNet. Oh, ResNet. Let's check out ResNet. ResNet. Hey, Ryan, how's it going? Oh, you had some the furted. Okay, you did it again. Wait, the fool. Hold on. Oh, the fool. Praise the fool. Wait, hold on a second. We've got Super Team and the fool. Hold on. We've got too many names now. Super Team. I thought you were the fool. Wait, what's going on here? You're confusing me. It's me, MTB. What are we coding? We're doing artificial neural networks today, a deep learning framework that we did from scratch. We did live on stream the past few streams. We did it in 2 streams, you guys. Although, I mean, if you do look at it, it's about 100 lines of code. If you get rid of all these to-do statements, which are going to make some cleanup here, we're going to do a little bit of cleanup today to make sure that we've got our algorithm nice and happy. Thank you, Quantified Quantum. We got some moderators in here. We got a moderated message. Ryan, I see some of your messages in there. The fool. Interesting. Yes. Hey, Stephen, how's it going, Shyam? Hi, Stephen. How are you? We're doing good today. We're doing very good. We're going to be doing some machine learning adjustments to the model that we made, our own custom from scratch framework, and we will be making it a little bit cleaner. So that's the plan. We're going to make it a little bit cleaner today. We'll just update this. And here, check this out. You want to compare it to this right here. Do this. Look at this. Check this out. 1, 0. Here we go. See this here? See how simple and clean this is? See how simple and clean all this is, Rick? And then you compare it to this, which is just a whole bunch of code that's kind of obnoxious. And this is only a 2-layer. This is even a deep learning code. This is not even deep learning here. It's not even deep learning, but this model is a deep learning model, and it's just so much cleaner. Look how much less code there is. Isn't that crazy? Isn't it amazing? I think it's really cool. In the YouTube, I'm not fool. Okay, super team. Okay, this is gonna be. We'll be able to keep track of it. Okay, so super team in Discord, the fool, but on YouTube, you're super team. Excellent. Shyam, Steven, recently I told you about app. Okay, I was making for the company I'm working on prompt management and collaboration tool, but my manager wants to be a teamwork, not by referring me and get his name. Wait, what? What? Hold on, let me read that again. Hey, Steven, recently I told you about this app. I remember the app, I'm pretty sure, making the company I'm working on prompt management and collaboration tool, but my manager wants me to be a teamwork, not by referring me. What does this mean? What does this mean, Shyam? Is this a reprimand of some sort? Are you getting in trouble? Are you in trouble, Shyam? Is that what's going on? I don't know what the deal is here. All right, let's check this out. All right, let's do it. So let's update some of our code. Let's do that. We're gonna update some of our AI code here. We're gonna make it. So we're gonna clean up a few things. We'll get rid of some of that. We'll keep the title going here. I do want to add in sigmoid because one of the tasks was from actually one of viewers in chat. We're like, hey, check this out. We found a way to update. We need to add sigmoid in. We're going to add some sigmoid. I think I have some sigmoid around here somewhere. Hey, same for me. I've not been able to look at the word fool the same ever since. I finished reading LOT. Well, Lotum. Wait, what is Lotum? What is Lotum? Wait, what is Lotum? Is that that must be a show of some sort. Super team. I also have another general question. In your Discord, where I can submit the hackathon project, which you have posted. Send it to just send the GitHub link to me or any moderator. And so you go to any moderator, and then we'll post it in mod chat. So just do a DM, send a DM or anything like that. Just send the GitHub link. just send GitHub link. Oh yeah, okay, so real quick. We do have a hackathon that we're going here with some prizes. So we've got a hack that is code quality. It's all about code quality, which is kind of what we're doing today. We're going to check this out. This is really cool. We are building a feed-forward neural network that, is deep learning. It's all the cool things. It's a framework, and it's all about code quality. That's what the hackathon's about. All about code quality. You've got 10 days to submit a GitHub repository URL, and that's how you do it. You just send it over Discord. That's the answer. Send it over Discord. And then you can get a prize if you win. And you win by having really clean code. So you can see this is pretty clean code. I mean, other than like the to-dos here and stuff like that. It's pretty clean code. So you compare that to like this, where it's just overwhelming. It's dense. It fills up most of the screen. It's kind of hard to read. It looks like a book. It's uninviting. And you kind of go back to here and you see, okay, this is a little bit easier. I can kind of see what's going on. You see how it's how clean and simple it is, and the functions is so simple and clean. So we'll be doing that. We'll be comparing that. So like this to like this, right? So these are the two comparators. There you go. Those are the comparators. I'm missing some of the chat messages here, you guys. All right, let me catch up. That's okay. Super team, you just go to our Discord, and then you can submit for the hackathon. Are you a bottom mythic blunt? That sounds like a question that is a personal question, doesn't it? Doesn't that mythic blunt? That sounds like a personal question. For sure. Juki, please. I don't know how to create an AI model. Oh, you came to the right place, Juki. You came to the right place, Juki. Please, how can I download an AI model and turn it into an API, which can be run locally on a website? Okay, so you can do there's a lot of things you can do. So you're going to use Python. You can probably get Flask going here. You can probably get Flask, do Flask Python. Flask, here you go. And then you can create a web server with Flask. And then you go to Hugging Face, and then you search for a model that you're interested in. And then you click on the model, and then it will give you instructions on how to use the model. Transformers. And you copy and paste this code here. And then you post the outputs, the generate model outputs, or into your what is it, Flask, the Flask segment. Here we go. So see how here's your app, and then whenever you run your API, so like maybe you have a / entry point, then you run your AI here and return the result. There you go. You've got a web server that can do AI. You just copy and paste these two things. You've got this here and this code here. Boom, you did it. Flask plus Hugging Face transformers, you're good to go. I mean, that's a quick, easy start. Lord of the Mysteries is a novel. Thank you, Echo. Lotm, Lotm, Lord of the Mysteries is a novel. Appreciate it. At Echo, yep. Shyam, let's see here. Go back here. Okay. It was my idea, but making politics by not putting my name in the architect or lead, and he wants his name to be displayed for the project to get credit. To get the credit, that makes sense. That's the way. That's how you get credit. You got to put your name on it. Super team, thank you. Yeah, no problem. Happy to help. Not one. I have 2 ideas. Oh, might submit one. Might get both working. You might as well get both. Get both of them working. Like, it really depends. You might as well submit more than one. Why not? We don't have any hard restrictions on that, but you never know. Or you can submit your favorite one. There you go. To be honest, I don't know if my project is a good CSV parser following an RFC. Oh, that's a good one. Then cleaning it up using specified data. That sounds really cool. Thank you. Thank you for the likes, you guys. Appreciate it. Okay, here. I can see those little icons show up there on the screen. Hold on. Fantasticals, your name. How's it going? Hey, I wanted to be a software engineer, but no knowledge in Python. Can you please help me? Hey, good news. Python is the entry point. That's where you want to start. So you want to do look for a YouTube series that trains on Python. YouTube is the answer. And then create a project. This is how you do it. You create a project for yourself, like a to-do list app or a calculator, which are really good entry apps into learning the language. You learn the language by typing it out on your keyboard, and that's how you learn it. You do really good. And then, of course, use the AIs to help you to say, hey, can you help me do this? And the AI will help you along the way as well. So you can use like ChatGPT to create a tutorial for you, and then you can use YouTube to then get some more ideas. But also, I'm here to help. If you have any questions, let me know. Thank you, Stephen. Not sure how to handle politics in the work life. Is you just don't. You ignore it. Shyam, in order to handle politics, you just don't. You just don't. That's how to do it. You just don't. That's the answer. Ignore Juki. So if I use Flask and Hugging Face transformers, I don't want to use the model local server. I want to use the server I'll pay for because I don't want any delays. Yes. So you run it locally. You got it. So you've got a server. You could be running a GPU server like an NVIDIA server. And then you'll use Flask. And then you have the transformers model with Hugging Face. Instant API, you can host every AI on the planet. You can host every AI and it will be hardware accelerated and it will be fast and efficient. There you go. There's the answer, Juki. You got it. Super team. Hey, Steven, do you know I'm working on a research project called Corp Disease Detection? Can you tell me some scopes where I can innovate or do something new? Sure, thanks. Happy to help. Yep, there you go. Innovate. So you need data. Right? You thank you for the likes, you guys. You need data. You need like actual images and like close-ups and things like that. And then you need to clean the data so that way you don't have any anomalies or anything that's going to pollute the AI or anything that you're training the model on. It really depends. Like a super team, like this is you can build some amazing stuff with AI and data. So I'm not sure where you're currently situated. Where are you situated, Super Team? Juki, so can I get a model from Hugging Face without having any license issues? Because I want to use it for commercial purposes. You got it. So you want to check to see if there's any license details on it. Usually it's like a MIT. If you see MIT on the page. Yep, see, license. Here. Yep, see it says MIT right here. Here at the top of the screen. So let's zoom in right here. All right, where is it? See, it says license. MIT license. This means you can do whatever you want. You can do anything. And now you can host the AI model, run it on a server and then sell it. And you can make money. This is how you make money, you guys. This is how you make money is build an API company. You can make it happen. Hey, Juma Tech and Software. Thanks. Absolutely. Welcome on in, Juma Tech and Software. Thank you very much, sir. But how do I connect with you? Fantasticals. Go Discord. Definitely do Discord. I think it's pronounced Supratem. Supratem? Supratem. Okay. I'll try Supratem. Although I don't know if it's, I've been saying team, but maybe it's tem, right? Right? Supratem. Okay. I'll try. Thank you, Quantified Quantum. I'll try Supratem. I'll see if I can remember. All right, here we go. Getting over here. But we connect by Discord. So here, I'll paste our Discord link. Where's our Discord link? Let me copy that really quick for you. Here's how we connect. Go onto our Discord, and there we go. Are you on LinkedIn? I am. I've got it up and ready. You can find me here. I'm on LinkedIn. So let's go here. Here we go. Here's the LinkedIn. There we go. LinkedIn right there as well. I'm actually creating my own CNN convolutional neural network model using PyTorch. Oh, Super Tim. Excellent. PyTorch. The best framework. I only use PyTorch. It's excellent. Choose a data set from Kaggle to work on. There you go. Yep. There you got your data. You've got your AI framework. You're good to go. And using CNN. You can use a CNN, but they also have vision transformers. So I would recommend checking out a vision transformer PyTorch. Here you go. Do a vision transformer. This is the modern approach to computer vision, right? If you're doing any computer vision, where you've got a model that you're trying to generate based on visual data it's important because there's correlations and you want to have self-attention between the pixels. And so vision helps a lot. But you can do a CNN. You can still do a convolutional neural network. It's still fine. It still does the trick. You can still do that. Let's see here. Let's go back. All right. Thanks, sir. Happy to help. Yeah, thanks, Quantum. Excellent. Happy to help. All right, let's do this. We're going to now we're actually going to get to some of the code. I'm really excited. Oh, this is so satisfying. Okay. I did want to bring in Sigmoid because we had someone. Hold on. Let's do this real quick. There is a file here. Jukiro gave us some ideas about Sigmoid, I think. /sig, back to C. Here we go. Okay. Given that the output is between 0 and 1, we want to use sigmoid. So let me add that in. That's going to be something that we want to do. Valentine, how's it going, Valentine? Welcome on in. Hey, everyone. Happy to have you here. Iron Ignite Place, like on Iron Ingot. I'm just like think of it like this. If I start learning AI today, how long is it going to take me to master it? Like learning AI and all the maths and stuff, it'll take so if you spent like all day on it, probably for a month, you would be perfectly fine. Every day for a month, no problem. No problem, you would win. But guess what? You still can't really necessarily fully master it because there's just so many details, and the industry is still evolving. It's evolving so much, and no one has figured out like the perfect algorithm yet. So you still have a lot of opportunity to learn, and since things are changing so fast, you have to just keep up. Even if you spent a whole month on it, you're already behind because something new came out. So it's best to always just keep up to date as much as possible. That's part of our job. I need someone to mentor me in Python. Valentine, here we go. We're going to do some Python today. So if you have any questions, let me know. We're doing some Python today. We built ourselves over the last few streams a deep learning framework from scratch using one library, NumPy, which helps us with the iterations and the for loops and things like that. Also, if you check this out, there's not a single if statement anywhere. There's no if statements in this entire file. Isn't that crazy? Where's the flow control? Where's the flow control? I thought you needed flow control to write software. Nope. Nope. You've got me a subscriber, sir. Oh, cool. Fantasticals. Thank you. Actually, really appreciate it. Welcome on in. Welcome to subscription. We will be doing a lot of computer science things on this channel. And this channel, we'll be talking about AI. We're doing AI right now. We're doing Python. We're doing no more Python. We'll even talk about some blockchain. That was one of the ideas from a previous stream that came up. Hey, what if we wrote our own blockchain from scratch? What does that look like? Because we wrote our own machine learning framework from scratch here. As you can see, here's our own machine learning language framework from scratch. But we can do it with blockchain as well. Build some consensus algorithms, you guys. Consensus. Juki, please, can you give me a small tutorial on how to embed a model in a website without learning how to create the model and how to get API from the model? Okay, here, I've got your idea, but it only works for certain things. It's called TensorFlow.js. TensorFlow. I think TensorFlow Lite. TensorFlow Lite.js. Here we go. I think this is it. TensorFlow Lite.js JavaScript provides a way to run pre-trained TensorFlow Lite models with a web browser and JavaScript environments, like in Node. So you can build it right there in your web browser. So if you don't want to run a server, and you don't want to spend any money on a server, you can embed AI models directly into a web browser or an app like your phone. And so that way you don't need to host the model anywhere. And then you can just use the web browser, which has WebGL and a GL accelerators built straight in so they can take advantage of any hardware that's already built on the devices directly. So you want to use TensorFlow.js is a good option. I think it's a really good option. There are other approaches, but this might be the most easiest one to go for. The challenge is, though, you're going to have a limit to which models are available. And if you want some of the other kinds of models that exist today that might be on Hugging Face, you'll have to convert them to a TensorFlow Lite model, and that might be a challenge. So there's some roadblocks there, but it is possible. Here you go. There you go. That's how you do it. I have CUDA out of memory error. Oh no, Peter Erickson, you need a bigger GPU. You need a bigger GPU, Peter Erickson. Valentine, exactly. I would like to start from scratch to learn this. Excellent. There we go. You so skinny, man. I know. I'm trying. We're eating as much as we can. I promise. We're eating as much as we can, and we will be gaining weight. We will be gaining more weight. I promise. That's actually a goal for me. It is a goal. I am working very hard to gain weight. Quantify Quantum. Stephen, how about we do a Friday stream reading a tech article like Primogen? Okay, Quantify Quantum. Let's do it. Quantify Quantum. If you have any article that you're interested in reading, we'll do it. Post it to the Discord, Quantified Quantum. We will do it. So that'll be Friday's stream. We will do that on Friday. Friday's stream. Here we do it. Let's post that in Discord real quick. Discord is right around here. There we go. Here we go. All right. So 1, 2, 3. 1, 2, 3. Friday stream. We'll do a what do you call it? We'll do a reading article. There we go. That's the plan for Friday. That's the plan for Friday, you guys. We'll do a Friday stream. We'll read an article. Which one? I don't know. We'll have to figure it out. I tried to learn AI, but it's so hard. It is, Muhammad. It is a challenge, I can tell you. But good news, I have a very simple AI right here. This is full-blown AI. This is like using pretty much the industry-leading, most advanced approach to building an AI model. Now, there's a whole bunch of other things that go around it, but if you look, and we're going to make some adjustments here, we're gonna make this clean and simple. So there is a GitHub on this. So let me see here. Thank you for the likes, you guys. That here, I'll post into our Discord again. There is a GitHub link. Where is it? Did we post it somewhere? Where did we post it? Here we go. All right, let's go to repositories. Here we go to repositories real quick. We'll go into our repository, ML from scratch. All right, here we go. This is the repository, and then you can see the file here that we were currently working on. This is the file. Isn't it simple? Look how small it is. Isn't this crazy? And we're going to make it even smaller today. We're going to clean it up and make it a little bit simpler. But this version right here is really easy to read. You can see this is AI. Where did AI right here? Look at how small it is. It's just so tiny. It's just so tiny. All right, here, let's post that in here. I'll post that into our Discord, and then just pop into our Discord to get the link. Okay. What? All right, let me double check here. Let me see if I missed any chat messages. Friday stream are good, but so hard. Please, I spent my time learning HTML and CSS. Is it worth it? It is. Fantastical's HTML and CSS is still very common. So the majority of people visit a website every day. The majority of people who are online with these apps, they visit a website every day. And so that is powered by HTML, CSS, usually some JavaScript too. So it is absolutely worth it. It helps. It's good to know. These are DSLs, languages, hypertext markup language, and cascading style sheets. Great for displaying information on the web. There you go. Muhammad, hello. Okay. Shivam, what is one advice you would give to someone who is trying to get into AI ML in 2025? Start with Python. That's the advice. Start with Python. So, right, Python, definitely start with Python. It's easier. It's easy to read. It's easy to understand. And then get into like something like scikit-learn. So to get started, so to scikit-learn and Python. There we go. I think those are some good options. That's some good starting points for 2025, I think. Juki, I want to be in my backend code because I said earlier I want to use it for commercial purposes. Okay, Juki. So then the only option that I'd recommend is using back to where we were. So you got Hugging Face, and then Flask Python, right? Those are the best options, and then you're good to go. And then from a web app perspective, you just make an API call to your server, and you're good to go. Make an API call to your server, and then you can return any data that you want, including AI. So that's the best, Juki. That's absolutely the best. Wait, I'm running behind on some of the chats, you guys. You're in for this Friday call auto session? Okay, cool. Plays. We'll see you on Friday. We'll see you there on Friday. Muhammad, programming is so hard for me. I spent so much time on my PC because it is hard. Don't worry. It never gets super easy. It never gets super duper easy. For me, I always have to look stuff up constantly. It's all about just sort of remembering some of the concepts and then applying them again later. But I still have to look up syntax. You guys. The tech man, how's it going? I'm not a coder, but this looks like crazy work. There's some craziness going on here. We got a bunch of things happening here. We got a whole bunch of things happening. I'm very excited. What's your Discord link? Quantified Quantum. Thank you for posting that in. You look so smart. How to become a smart programmer? Just practice. It's just practice. You can learn it pretty quick. It was actually pretty easy to get into. You just try out really simple things and then try out something a little more tricky, and then you just keep building from there. So just something simple like this, right? So you got a Python terminal here, or you've got a terminal window open, and then you say Python, you just press enter, and now you can say print hello, like this. There, you just wrote some code and you ran it on your computer. It printed, and then you can say print 1 plus 1. There you go. Another program. Done. There you go. So you start simple. Start simple, you guys. You got to start simple. Could never get my brain around more than basic Python. Hey, the tech man, good news. Once you get into Python, it basically everything else is the same. It's all the same after that. It's all the same. Isn't Fast API better than Flask? It is. So yes, you're right. In terms of performance and speed, Fast API is better, but Flask is a little bit easier, I would say. Flask is easier. Fast API Python. Python. There you go. Let's check out what this looks like. Tutorial user guides. Okay. Here we go. So let's see. There's got to be like a first. Let's look. Let's take a peek. Okay. Oh, you know what? That looks just as easy. That looks just as easy, doesn't it? Okay. I take that back. They made it better. Wow. They've made it some. I remember when Fast API first came out, it was not this simple. They've made it way better and faster. Okay, here you go. Fast API, you guys, a better Python web server. So Flask is still fine, but Fast API, there you go. Check this out. This is a lot. This is very clean. Look at this. Oh, this is beautiful. And you can do the same thing. So you can just add Fast API and Hugging Face. You're good to go. You've used Fast API. It's way better than Flask. Okay, here we go. We've got some. Hey MD, how's it going? Welcome on in. Where we go? 410 or 373. Wait. What do you mean? What do you mean 410 or 373? I'm not sure. I don't know. Wait, 410 is bigger, so go with the bigger one. Please, does CS student also learn HTML and CSS? Yeah. Yes. Yes. HTML and CSS. They're helpful like languages. They're document space for the most part. Thank you for the likes, you guys. Are you late? MD, are you late? Only by 36 minutes. No way. The tech man. I'm not understanding anything, but I done enjoy you geeking out. All right, cool. Well, here's the thing. That's the first step. The first step to understanding something is not understanding something. That's the beginning. You're right at that's totally fine. Okay, thanks. I will. Wait. Yeah, really mean Jim. Yeah, really mean it, Jim. You really mean it, Jim. All right. There we go. All right, here. I'm so excited about this part. Okay, this is what I really want to do right now. I really want to update this and make this better. Okay, let's do this. So I did want a sigmoid function. I wanted to bring in a sigmoid function, and I know I have a sigmoid function around here somewhere. Here we go. Here we go. We can just copy and paste these guys right here. Let's grab these. All right, so let's bring over here, paste that in like this. There we go. And then I want to put them on a single line because it's a little bit cleaner. There we go. Okay, so we've got define, see, there's a layer class there. A bit, yeah, you're a little bit late. Here we go. Now we're actually coding. So we've got our sigmoid activations. Sigmoid, there we go. Let me double check. All right, cool. Let me get rid of some of that. All right, cleaning up. So we've got our sigmoid. We've got our layer here. And then I want to make a model. I'm going to do a class model, and then it's going to be it's going to have some good stuff in it. We're gonna have some good stuff. We're gonna make it a little bit better. You deserve a sub. Thank you, the tech man. Appreciate it. I'm a sub. Gonna be around. Definitely interesting. Very great to hear. Very great from here. Muhammad, I want advice from you. Okay, what is the advice that you're looking for? Me opens a JetBrains IDE in your stream, fan. The moment you open JetBrains, yeah, exactly. The IDE, it just consumes all the resources on your computer. Boom. Kristen James, how's it going? Next, after the sigmoid, you should do the rectum. Wait, are you talking about rel-u? Are you talking about rel-u? You're probably not. You're probably talking about something else. You're probably not talking about rel-u, Kristen James. I'm pretty sure. Okay, let's see if we can clean some of this stuff. All right, so I know this. Okay, so this part I wanted to do different. I want to do this because we don't need the gradient to be stored in self. So I wanted it to be like this, gradient, and then we go like this, and then let me see here, gradient. So we don't need that anymore, and we don't need that. There we go. All right, there we go. Let's double check to see our program still runs. Okay, so we need to go up here, like that. Maybe self. Wait, yes, self. There we go. Let's clean that up. There we go. Is it going to run? Is it run? Okay, we're still running. We're in good. We're good. Hey, Drawing Brothers, welcome on in. Happy to see you here. Welcome in, Drawing Brothers. We're doing our Python machine learning framework. We're making some adjustments. We're updating it. So yesterday, we fully succeeded in getting our deep learning framework to work, and we did it from scratch. And I was so excited and so happy to see it working. It was very happy. It was like a wonderful adventure. And today we're making it a little bit better. We're just improving it. We're just going to improve it. We're going to clean it up a little bit. We're going to clean up. This is important because we do have a hackathon, the Code Quality Hackathon, which is going on right now, this very moment. You can submit your own project if you think your code is production quality code, where it has a clean, simple, easy to read, is not overwhelming, and has a low footprint. Then the Code Quality Hackathon is for you. We've got prizes, and then you just submit it to the Discord channel. Send it to a moderator. Send it to a moderator, your GitHub link. Send it to the moderator, your GitHub link. And so this is the kind of code that I'm looking for. This is what we're building right now, is the kind of code we're looking for. Okay, let me catch up with some of the chat messages here. Sorry, let me pull this in real quick. Okay, here we go. I've been trying to build an app using AI. Good. To be honest, to be hosted locally, but I've very little knowledge about building the database structure. Oh, how do you go about it? Or is this just a Python stream? Dibs, Drex, everything goes. So start with SQLite. I like SQLite. That's actually a really good one, because then you can just pull it up and then run it locally within your own app, your own environment, and on a server as well. It's very fast. It is performant, so it's actually perfectly fine. You could spin up a Postgres or a MySQL as well, and those work. But if you're talking about schemas, you could just design what attributes you want to save about a user. So if you're doing a schema, all right, let's go over here. Let's open up a text editor. So you're doing a schema for a user, schema for user. You might have like the user table, and inside the user table you have a name, an ID of the user, email. You might have an email. Depends on how you like to. Right, so you got different things here. So then you you ask the AI to create a table for you for that. So what else, like age maybe, or something like that. So you've got all this information about a user, and then you ask the AI create table syntax, something like that. And then ask the AI to create the table for you, and then you'll have a table created, and it works in SQLite. It'll work in Postgres, and it'll work in MySQL. There you go. I think that was a very quick starting point, but you just got to start with your schema. You got to start with your schema. That's kind of the answer. All right, let's see. Getting back over here to some of the chat messages. I did an interview at ARM. You did? You did, but it went very bad. Oh no, I feel not good because I wasted a good opportunity. No, Muhammad, no. Oh, that's terrible. Oh, that's such an amazing opportunity to get that interview, and you didn't do good. Oh, that's terrible. Oh God, somehow I caught up. Chat Neovim, or never mind, too early. Okay, no, all good. He did mean Relu by rectum. He did. Wait, Super Tim, he did. You think he did? I don't know about that. I don't know. I'm not sure, but maybe. Oh, wait. Are you sure? I don't know. I'll have to look that up later. James, Christian James. I'm just kidding. LOL. I was going for a DeVry for software engineering, but I'm considering a boot camp instead because I don't feel like I'm learning enough to be ready for a job. Hey, don't worry. I wouldn't say. I mean, there's just too much to learn. There's too much to learn. So a school, any program that you do, like you go to a class for, they might give you some foundational knowledge, but it won't be industry. What do you call it? It won't be ready for industry because industry is far ahead of educational institutions because industry is bleeding edge, right? We're at the forefront, and it's always changing. It's always evolving. It's all about just keeping up. And you just got to keep reading, got to keep learning, got to keep trying things out every single day. It's part of the job, is just being up to speed with the industry's state of the art. State of the art. That's what you got to do. That's part of the job. Don't worry about feeling like you're ready. If you feel like you're ready, you're not. You're just not. So don't worry ever about feeling like you're ready. The tech man. How different is coding for game creation? Oh, it's quite different. Different from other things because I have made a game in Unity. Oh, cool. C#. There you go. It took me so long, even though it was very basic. Yep. There's a lot to games, right? Games are the most demanding application on a computer because it requires the most resources, other than AI, of course, right? Other than AI. But gaming is huge because it needs to be fast, it needs to be fun, it needs to be entertaining. You need to have pretty graphics. You need to make sure the algorithms work properly, and they're the most intense algorithms because they need to be fast and efficient. But also, you only have so much hardware to work with. So building a game versus building an enterprise app, completely different. You've got way too many resources for an enterprise app. So that's a lot easier, and there's a lot of opportunity from business in that perspective. That's why I wanted to be a game developer growing up, and that was actually my objective, and so that's where I focused a lot of my time was in game development. But it turns out, enterprise, you guys, enterprise software, it is a little bit easier to make money on enterprise software because you don't have to worry about there's a lot of people trying to make games, and it's a hits business. Was it like 90% of games don't make it big? Over 90%? Oof, that's terrible. So it's a challenge, and you spend all this time trying to make an amazing game, but it might not make it. But if you go into enterprise and you start doing, industry business, things can be different there. Hey, Jack Keeble. Hi, been a while working on a Python today. We're doing Python. We did a machine learning framework from scratch, Jack Keeble. We did machine learning from scratch. Anyone? Yes. Thank you, Quantified Quantum, for mentioning. DM Quantified Quantum, direct message Quantified Quantum. If anyone has a hackathon submission, we've got a hackathon going on right now, up to the 17th. We've got 10 days until it closes. You submit a project that has good code quality. The rules are in the Discord channel. You guys. There we go. Thank you, Quantified Quantum, for mentioning. Okay, let's get back to the CEF. We're almost through all the chat messages. Drawing Brothers, what type of projects we need to submit? Anything that's good code quality. So check this out. This is pretty clean code here. Pretty clean code. You can see how simple it is. We're going to make some adjustments. I'm really excited to make this improvements today. We're going to make some improvements on this. But you compare that to this. Like, see how they're different? So this one's clean and simple and easy to read and approachable. But you look at this one, and it's overwhelming, and it's daunting, and it's difficult to follow. It's like easy, difficult. Right? You can see the difference, but we're going to make this even better. We're going to make it even better, you guys. So I did simplify that, so that's gone. So we made that better. This we already modified. We did that. We're good there. So you can see how clean and simple this is. Look how simple and clean all this is. It's actually very easy to read. You can see how it's all built in, and the functions are clean, and you understand what each function does. It's only like two. Isn't that crazy? Look, 2 lines for each function. Isn't that beautiful? I think it's just gorgeous, and it's so powerful, and it's deep learning framework too. All at the same time. I think it's amazing. Thank you for the Discord link, Quantified Quantum. Thank you. What type? Let's see. Hello, brother. I have completed my B.Tech CSE. Congratulations, movie for everyone. You did a good job. Good job at completing your B.Tech CSE. Your CSE. Congratulations. That is a job well done. The tech man, well, if I'm learning accounting and more of the commerce side of industry, I'm sure learning this will give me an edge. You're totally right. These are things that will give you an edge in industry. Common languages that are used for almost every role, including the game industry, including financial industry, every tech industry, HTML, CSS, JavaScript, and Python. Those are the common languages. Not equals bot. It's only about code quality, Drawing Brothers. You got it. All about coding quality. Unknown Gamer. Hello, bro. Remember me? Unknown Gamer. How's it going? I'm not sure. wait. Maybe a little bit. Maybe you came in on one of the streams. Maybe Unknown Gamer, because your name is actually fairly memorable. It's fairly memorable. But welcome on back. Happy to have you here. We're doing some Python today. We're doing some Python, and we are updating our deep learning. We're actually almost there, updating it all. All right, so let's clean up some of the stuff. We don't need that anymore. The delta is the error. And then we're going to make some adjustments here. I'm going to turn this into a model. Well, I'm going to go. It's like 1 a.m., the tech man. Okay, thank you for stopping in. Thank you for hanging out for a little bit here on stream. We're going to be finishing up this framework here, and we're going to make it clean, and then we're going to try to use it for something. And that is what we're going to be doing because 1 a.m., you got to be sleeping at 1 a.m. There you go. 1 a.m. All right, so let's get rid of some of this stuff. So this is for monitoring, so we're good there. Simplify. Okay, this is what I want to do. I'm going to make a model class. We're going to make a model class that has our layers. So we have layers like this, L-A-Y-E-R-S. There we go. And then we will have self.layers. There we go. L-A-Y-E-R-S equals layers. We're gonna clean up. We're gonna clean this. There we go. No, not lambda. Layers. Layers. There we go. Perfect. And then we're gonna have a def forward, and then self. I think maybe inputs. Okay. There we go. Pass on that for now. And we're gonna do a backward, and then backward will be gradient. There we go. We're gonna pass on that, and then I think that's. Oh wait, no. Here, I've got a better idea. We'll have a fit. We need a fit function. Something like that. We need a fit function. We'll figure it out. We need a fit function. Drawing Brothers, can we submit multiple projects? Yeah, totally. It's totally up to you. Within the spirit, right? Within the spirit, it's good to like submit one project that you find is your favorite. But if you have two projects, that sounds okay too. Unknown Game, you just bought an RTX 5070. Ooh, very tasty. An Ultra 9. That's a good CPU, the Ultra 9s with the high number. 275HX laptop for AI and ML studies. Is that good enough? I think so. What you need to know, what is the RTX 5070? Well, how much RAM does that have? Let's check this out. RTX 5070, what is this? Oh wait, I gotta type that right. 5070. There we go. How much RAM is 12 gigs? That's not a lot, but if you're doing what we're doing right now, you're totally fine. If you're doing what we're doing, you're totally fine. Most models will perfectly fit within 12 gigs. But if you're doing any of the large language models, a lot of them, well, you'll have a challenge because they're pretty beefy. They are pretty big. That's a pretty good one. Before I go, when do you stream? Oh, the Tech Man. Usually around this time of day. He streams every day except for Saturday and Sunday. Thank you, Quantified Quantum. Yep, on the weekdays, Monday through Friday, every day except Saturday and Sunday, we are live. And so we go live around this time of the day. Gotcha. Cool. Happy to help. Around this time, an hour ahead or behind, give or take. Yes, because I've got meetings. I'm usually booked up in meetings. Steven, how do I learn money? How do you earn money from my desktop app? Oh. You put a price tag on it. you got to find a selling point. So what I like to do is called a freemium. It's called freemium, where you give away part of the app, but then you have paid features. And so you need to talk to your users. Drawing Brothers, talk to your users, see what they like, what more features they would want to use in your app, and then add those features. And then for those who gave you, a good advice for adding those features, you can give them a freebie and say, hey, thank you so much for helping me out. This is a new paid feature, and you get it for free for helping me build it. And then you can go to market by selling to everyone else who wants a similar thing. There you go, Unknown Gamer. Mine has 8 gigs of VRAM though. Oh no. But you have 1.5 terabytes of DDR storage. Wait, DDR4? But that's a lot of RAM. How did you get 1.5 terabytes? That must have been expensive, Unknown Gamer. That's expensive. I only have 128. I'm not even anywhere near a terabyte. That's amazing. Wow. Thanks, Drawing Brothers. Happy to help. Okay. Let's see here. So we've got our forward pass. So we'll do, how do we do this? How do we do this clean? So we could say for let's see, layer in self.layers. We'll do this layer. Let's see, layer.forward like this. And then we say inputs. inputs. Here we go. Get rid of that. So that'll do the forward pass, and then let's see, out equals, or well, actually, what we could do is we could override it, so that way we keep things clean. So out inputs. Here we go. I think what we could do, and then we want to return out. There we go, something like that. But we can do out. I think we could say we could do this. We could do out or something like that. We could do this, which seems weird, right? Doesn't that seem weird? Check this out. Check this out. Let's do that. We go Python. So if we wanted to see, so we see 1 or 2, you'll see. Wait, I got to type that. 1 or 2, you're going to see 1. But if you say 0 or 2, it's going to return 2. See, it's called, what is this called? Short circuiting. It's called short circuiting. So if out is defined, if out is defined, so that'll work there. We could do that. We could do that if we wanted, but I don't know if it's clean. I don't know if it's clean enough. I'm not sure if it's clean enough. This is a very smart Liblimen. This is a very smart Liblimen. Curio shop slop. Okay, thank you. Thank you for mentioning. Appreciate it. Tomas, hey bud, are you building here today? What are we building? Okay, so we've got we successfully have built from scratch our own deep learning framework. From scratch, using NumPy to help us out. We use NumPy to help us out. Today, we're updating it and making it just a little bit cleaner, a little bit easier to use is what we're doing. Unknown gamer, sorry, I meant 1.5 terabytes read and write speed with 32 gigabyte DDR5. Oh, got it. Okay, so your hard drive is 1.5 terabytes. Got it. Okay. There we go, 32 gigabytes of DDR5 RAM. Okay, that makes a lot more sense. I was going to say, it's like, do you need that much RAM? Like 1.5 terabytes is like more than you need on a hard drive. You can buy that much RAM. You really can. I know it's possible because I've actually pulled up machines that do it. Please, what do you mean when you say clean? Dibs. Okay, so it's easy to read. Simple words on the screen. The functions or the methods, they're very few lines of code. So see, look at this function, this method right here. This method that you see here on screen, it only has 2 lines of code in it. Very easy to see, understand what's going on here. And what we should also have is some annotations. This is forward pass, which is also the predict function, or we should say method. It's a method because it's in part of a class. That's the only thing different. A method is part of a class. A function is not part of a class, and it can be used anywhere. A method, they're the same thing though. They're basically the same thing. So this is what I mean by clean, is we've got some good annotation, and then we should also have some unit tests, to be honest. We should backward propagation. Spell. I'm going to say spell. Okay. For training the model. Yeah, there we go. Training the model. There we go. So we're just going to clean it up to make it clean. So we're tidying it up. We're making it look a little bit easier to read, a little bit simpler. Code that is kind of the reader. It's kind of the reader. Tomas, you've got the ultimate. That's like the ultimate. You've got the ultimate phrase there. How did you figure? Okay, that is it. Code that is kind to the reader. It is very helpful. It's code that you write that is beneficial to whoever is going to come along in the future who has to read it. So you want to make sure that your code is legible, it's clean, it's approachable, it feels effortless to read, it's lightweight, and it's easy to understand. You see, we only have a few lines of code in here. So no, compare it to this here. This feels daunting. I have to spend a lot of mental energy to walk through this code that does not even as much as our code does here, right? Because see, it's not like easily we haven't segmented the code in a way that is clean and easy. So update model weights with gradient or the delta of learning. The delta of learning. I don't know the delta, which is basically the error. I would say adjust error, which means, let's see if I spell gradient properly. I got to spell gradient. Here we go. which means it simply is slowly adjusting the parameters of your model, of your AI model, so that way it learns. You're just incrementally training your model, right? We want to slowly adjust the training of our model. That's the idea. Slowly adjust the training of our model. There we go. Leaves a comment on my project. Add +1 for each hour to spend debugging. It adds +1 to 237. There's a lot of hours. That's a lot of hours, Unknown Gamer. In the future, we will see cloud-based programming for learning as well. We won't need hardware much. Oh, you're talking about server versus client. It's been a pendulum over the years. We switched from like heavy servers to lightweight servers, and to heavy client to lightweight client, and it kind of goes back and forth over time. It's kind of crazy. But yeah, our systems are powerful enough to run all your code locally, but it's also perfectly fine to run that on a server-based environment where you don't need to worry about hardware as much. What do you think? Yeah, I know companies provide servers, and every program is mostly ran on a server. Yep. I mean, basically, for the most part. But hardware is getting really good now. And so you can actually run heavy-duty AI models. You can run heavy-duty AI models on your phone directly. On your phone directly, you guys. 2 equals on. Got it. Type the typos that come in every now and then. Spent on debugging. Lots of spent time on debugging. Dibs Drex. Been here barely 30 minutes, and I've learned so much already. Really? Do you stream every day? Almost every day. So Monday through Friday. We stream Monday through Friday. 5 days a week, you guys. 5 days a week. MD, hope one day I will be able to make logics. You could do that now. When I'll learn programming like experienced developer, I'll be allows programming to contribute to open source. You can do that now. Don't wait. Don't wait for your skills. You don't need to. You gain your skills by doing. Do not wait. You already have enough foundation to contribute to open source. Just make it happen. Don't wait. Start today. You guys start today. He streams every day except for Saturday and Sunday. You got it, Quantified Quantum. Every day except for Saturday and Sunday. All right. So we're going to update this so that way our model looks like this. We're going to say layers equals this. Before I do that, I want to make sure that everything's working fine. I want to make sure all the things are working good because we're making a pretty big adjustment. Model of ANN, or actually it's DNN. We're doing DNN, which is deep learning, a deep neural network. The DNN model. The DNN, there you go. Deep learning. Tomas, I've only caught the stream a few times, and I found it really helpful. Great energy too. Thank you. So happy to hear that it has been helpful and beneficial. That's the idea. We're doing software engineering together. We're learning things together. We'll be doing more assembly. We'll be doing some blockchain from scratch. So we did AI, a deep learning neural network from scratch ourselves. We did that here. We'll be doing blockchain from scratch as well. And there's just so many other cool things we can do. I break problem in chunks. That's a good way, but I can't think logics. Hey, it's all okay. It all comes in time. Don't worry. It's all coming time. What are we training the model to do? Right now, we're doing a toy model that can do the XOR operator. It can do the XOR operator. So here's our training data. Basically a spreadsheet, but it's a simple a binary model, right? So we got a simple binary model. We got our inputs and our outputs, our features, our labels, right? These are all the same words. So your input data or your training data, your features right here, this is data that you want to train on. This is this data source. And then you've got your labels, your output, or your expected answers. The actual answers. Not expected, the actual answer to the thing. And then you train the AI on this data set right here. So that's what we're doing right now. It's just a simple toy data set. You call it a toy data set because it helps you validate that the model is working. So that's what we're doing. Hey, Logan, how's it going? Welcome on in. We're doing some AI today. I would like to be able to massively appreciated. Hold on. Let me read that. A like would be, oh yeah, press the like button, you guys. Press that like button. Press the little floaty heart icons and things will come on in there and on the stream. Okay, let's get back to our code real quick. All right, here we go. Here we go. So we've got our model, simple model, and we've got our layers. We'll have our layers. Why would having the PID process ID cores utilization? Wait, what? Oh, thank you for the likes, you guys. Open at the top. Oh, gotcha. Limiting the code screen. Well, what we could do is we can hide some of it, and let's reduce some of that code. Let's hide it. All right, so we'll do. Thank you for the likes, you guys. Appreciate it. Resize, pane. There we go. Resize pane -u, and we'll say 4. There we go. There we go. So now we added. Let's do it again. Let's pop this up here. Resize pane. Where is that? Pane -u, and then we'll do 3 there. So now we'll only see the top of the screen. So now we've given most of the screen to code. Most of the screen is code now, and I can still basically see that I've got cores available. So I think that's good enough for now. Good idea. So there you go. The HTOP is now not limiting so much. Hey, hi Steven. Which laptop do you use? A MacBook Pro. I'm planning to buy a MacBook Air M4. 16 gigabyte. Is SSD good enough? If you can get more memory, I would recommend more memory because 16 gigs is not a lot. 16 gig is not a lot of memory. You need more. What are your thoughts on Moore's Law being dead now? Unknown Gamer. Okay. So it's still, in a way, still active. So we're still able to create more and more transistors. Now, of course, you're talking about like maybe the frequency, the clock frequency of the processors hasn't really gone above 4 or 5 gigahertz. That seems to be an upper limit, but don't let that slow you down because we're able to fit more cores onto a single die, right? Onto a single process. And now our dies are massive. We used to have like little tiny dies that were like this big, but now our dies are huge, like mega dies, super dies, and they're just massive. And so from a Moore's Law perspective, our compute is still accelerating at the same rate. We're still having the ability to compute at the same rate. And with quantum processors coming out, we'll even outpace that dramatically. So there's a lot of talk about Moore's Law being dead, but I don't see it. There's still way more compute capacity that we've given ourselves access to that has massively outpaced even Moore's Law. In that general, I would say Moore's Law is still tracking. So you can't really discount it. I still think it's fine to say Moore's Law is still okay to be considered. That's good. Okay, here we go. Let's get back to some of our code. All right, got it. Updated it. So now our screen is a little bit bigger. Got more screen real estate. Okay, so where did we have any more to-dos? Okay, so okay, this is the last to-do we have on here, isn't it? Yes, this is the last to-do. Okay, this is the last to-do we got here. So we've got our model, we've got our layers, and then we got our out, and we got our fit. And our fit is going to be, how do we want to do that? We want to train on some input data. So maybe what we'll do is we'll say features and labels. Like this. We'll do features and labels, something like that. I think that's a good idea. Features and labels. And then, let's see. I kind of wanted this to be, a company managed to use light instead of electricity and made a CPU with terahertz frequency? Unknown Gamer, are you serious? Terahertz frequency? You know why that makes a lot of sense? Because light and electrons running through this metal circuits generate a lot of heat. They generate a lot of heat. So if we can build a processor like a light-based processor, a photon-based processor that does not generate heat, you can make those frequencies go to the moon. That is so cool. Thank you for the likes, you guys. That sounds really cool. Terahertz frequency, that's amazing. I want that processor. That sounds cool. Thomas, another scaling factor is efficiency. Same compute power for less energy. That's a good point. I think this is where we'll see some development in the next few years. More compute for more efficient compute. That makes sense. He's talking about photonic chips, by the way. Oh, thank you, Nadanova Music Mix. Photonic chips. These photonic silicon chips that can power the future of compute. That sounds really cool. I'm going to be impressed to see. So I think right now the existing photonic chips, don't get me, let me know if I'm wrong. They're only able to help accelerate certain math operations like multiplication, which is, granted, one of the most challenging computational tasks is multiplication. But like general purpose gates, I'm not sure if they've done that yet. Have they made it? Have they made a general purpose gate so we can have flow control and branching and things like that? Or are they still like application specific accelerators, right? Like ASICs. Is that what an ASIC stands for? Application specific hardware? What is that? It's a very specific chip that can accelerate certain tasks. Good evening, sir, Mr. Lamb. Pleasure to meet again. Happy to have you back. Welcome on in. We're doing some AI today. What are we making? Utsav. We are making. We're adjusting our machine learning model that we built from scratch yesterday and the previous day, and we're just making it a little bit better. We're just making it a little bit better, like a little bit simpler. So let me make sure this still runs. Is it going to run? Because I don't want to have any. Yep, we're good to go. Okay. So we've got this. What we want to do is improve this segment here. I want to make this segment better. When we'll be moving on from silicon chips, we'll have exhausted the node size. Oh, we'll have something new. Do you know any new material? That's actually a really good point. So silicon and some other metals are currently being used right now, and they can only get to so big, or we can only make them so small, because at a certain point you start getting noise, and it's also difficult to print them onto the die because of their size. And then really we're almost to the point where single atoms will be the size of a transistor, but we're not quite there yet. We still need quite a few atoms for a transistor, but the 2 nanometer processing is really we're approaching that, right? So as soon as we get to a single atom, then we can't get any smaller, right? I don't know what it's going to take, what kind of material is available for us, but there we go. Oh, it's called a company called TerraSense. Is it Quantified Quantum? I want to check that out. Let's check it out really quick. All right. TerraSense. What is it? Terahertz equipment for terahertz imaging. Wait. Time out. Is this actually new generation terahertz imagers? Oh. So, okay. So these aren't like they captured information. They're able to read, they're able to see data at a high frequency. Okay. So you can capture and read data, but they're not processing anything. They're just photosensors. These are photosensors. So, but thank you, Quantified Quantum. This makes sense. So they're able to capture photons, but at a very high rate, but they don't actually process anything. Up to a terahertz. That's crazy. You guys. Unknown Gamer. Might Matter is the company name who made the work model for this first. Wait, let's check that out real quick as well. I want to check that out. It might matter. Let's see. Might matter. Light matter? Did you mean light matter or might matter? You might meant light matter. Photonic supercomputing company. Let's see here. High bandwidth scale up. Oh wait, I've seen this. I've seen this before. Chips are becoming physically larger and more powerful, power hungry, to fundamental physical limitations of transistors. Compute performance roadmaps are now defined by silicon area per package. That's a problem, and the number of processors tightly linked to the high bandwidth scale up domain. The quest for AGI is to drive this trend at warp speed. Okay, so the way to get to AGI is what they're saying is you need a new kind of processor, a new kind of chip that can scale beyond silicon. Can go beyond silicon. A bright foundation of bigger chips. Thank you for the likes, you guys. We enable silicon era per package silicon roadmap. Shatter the concept of beachfront. I don't know what that is. The concept of beachfront and bring network radices. Wait. Radice. What is this word? Radices to new heights and breakthrough interconnect with packages and technology and platform. The passage. We sell the photonic chips that we're making and building AGI possible. So they're going to say our chips are going to be responsible for making essentially human intelligence, but from an AI perspective. Artificial human intelligence and the lasers that power them from a single reticle to wafer scale. The world's fastest and first 3D stacked photonic chips. That sounds really cool. Whoa, look at that. Whoa. We get zoomed in on this. Okay, so we got some 3D stacking going on here. This sounds really cool. It sounds really cool. Accelerating AI through the ecosystem's collaboration. There we go. It's really fast and energy efficient. That's what we want to go for. Energy efficient. Light matter, you guys. It's called light matter. Very cool. I tried out your theory to mine crypto through the depository participants and blend it with local UK traffic. And it just kicked me into a virtual platform and got locked out. Oh no, Mr. Lamb. Uh-oh, you got locked out? That's a problem. Light matter. There we go. J-Do, how's it going? G-Doge. How's it going? Birdo or Bido. J-Do, why not just use fiber optics inside chips? Oh, your message went away before I could read it all. Oh, no. Okay, let's see if we can finish this. All right, so we do have some time left. This is what I want to do. I'm so excited. Every time we get through reading chat, and then I get to go back to the code, and it's really exciting because we were going to build this. We're going to make it. I want to build this part of it. So this part is just going to clean up. It's just going to do a little bit cleanup. Let's do this real quick. Let's do def backward. I just want to do this as well. Self, and then we need something here. We need something. I don't know what this is. We need something there. It's going to be there. And then basically it's going to be this, right? So we need, so it'll probably be gradient. No. Yes. Okay. So we'll do that. We'll say gradient. And then in the fit, we can do that there. So we can do that here. So we'll do forward, which we need this. This will all go into the fit, basically. Naughty Nova Music Mix. Can we build a deep learning library in C? We totally could. In fact, PyTorch is written in C++, and it is used for, making it really easy to do AI. But you can do the same in C. In fact, you can do the same in Rust. As you can see, it's very straightforward. Like this layer right here is actually the majority of AI. Like this is the important part. It all fits right now on your phone or on your computer screen. Check this out right here, right now. What you're looking at is a deep learning neural network. And it is a single layer, but when you add them together and you stack them, you get deep learning. And that's how this works right here. All on the screen right now. 100% of the code that is important is represented right here. That is some clean code right there, you guys. Clean code. And look, the methods, the non-initialization methods, they all only have 2 lines of code in each of them. Isn't that cool? How long have you been coding for, bro? EthamD, since I'm going to use a really long time. In the 90s. In the 90s. There you go. For many years, decades. We've got decades of coding, you guys. Can you teach me how to hack Lamau? Yes, I totally can. Probably some of the cool things to hack are Ethernet frames on the internet. You can see a lot of cool stuff in Ethernet frames. There's a lot of information that you think is private, but it's not. It's not private. Ethernet frames, you guys. Unknown Gamer. I also heard that we might go from binary to ternary, bro. So there's no need. Unknown Gamer. You might be quantum processors. They're basic, like your binary 1 and 0. But then you heard trinary, which is 1, 0, and 2, where you have 3 states. You could do that, but it's not necessary. It's not like necessary from a traditional binary compute perspective, where the real acceleration is why go to trinary when you can go to infinity? Why not? Why go to trinary when you can go to infinity? That's the answer. So these quantum processors, every qubit is infinite. It's infinite because it can spin in all directions at once. It spins everywhere. It's everywhere between 0 and 1, which is infinite. Why go to trinary when you can jump straight to infinity? That's the answer. That's what I say. So quantum processing is very exciting. We're in the future with quantum processors. Bro, I was born in 94. EthamD. Yep, I was coding. Back then. I was doing software engineering. Hey, Julex. Some people JavaScript can't learn programming or just can't learn programming. Not even worth teaching them. Hey, it's always a challenge. It remains a challenge to be a coder. It always does. Quantum processors, maybe until a snapshot is taken. Okay. We've got a lot of time left. We still have a lot of innovation to going. Maybe meanwhile we could do some ternary processors, but I think we could just spend all of our effort on quantum processors, and we can go quantified quantum. Talking about quantum processors, but yeah, Julex, don't worry about learning software engineering and coding. It remains a challenge, and it does take some discipline, but I think it's just realizing that you never know everything, and being okay with it is probably one of the hardest challenges. It's probably one of the hardest challenges. If I had your brain, I'd throw mine out. Hey, no, don't do that. Don't do that. Your brain is perfectly fine. You just got to use it. Your brain is beautiful and wonderful. Cerebrano, logo, your brain is beautiful and wonderful. My brain is filled with a whole bunch of things that I learned over the years that are no longer valuable because AI has taken over and we don't need a lot of those things anymore. Just use AI to write the code for you. You're good to go now. Why bother with all the things that I've learned? We're doing coding. We still do coding for fun though. It's a lot of fun, you guys. Sir, I'll forward out a query. If we have a hypothetical spin hardened virtual machines and chain multi-hop VPN, can I actually breach through DoD classified networks? No, you cannot, because DoD classified networks are air gapped, right? These are air gaps. You cannot get into these systems because they're not connected to the internet. You cannot get into these systems. They're not connected to the internet. The only thing you can do, even if they have, it's possible they're probably, they even block all communications out externally. So getting into DoD, you need to have physical access. And the best way to do that, you can hack through social engineering. And if you watch Mr. Robot, the TV series, they use social engineering a lot. And that's probably the weakest. That is the weakest security aspect to get into the DoD. If you're interested in that, the malicious activities, you guys, what do coders create or do? Desert Eagle, we build everything. All the code, everything, the YouTubes that you're seeing now, the chat messages, artificial intelligence, all the software and hardware, it's all that's happening. That's all the things. There's so much. Our whole world relies on software, you guys. Our whole world is software. I heard that we might see ternary in daily life, but for CS students, it might be quantum. Unknown Gamer, yeah, I think the answer is quantum. I really do. I really think the answer is quantum. The Mr. M, getting into IT sucks in 2025 for juniors. Hey, it's always a challenge. Don't worry. Everything that is difficult is worth doing. If it's difficult, it's worth doing. Keep going. Don't give up. Just realize, yes, it is a challenge. It's okay. It's okay. That's a challenge. You just got to make it happen. You just got to get started. How can we get AI to code without handcuffs? Without handcuffs? Wait, what? Okay. So you're probably talking about some of the models that are like, what do you call it? Gated by security precautions. And they prevent you from writing malicious code. If you want to write malicious code, I think you can do things I think it's go to Olama and Dolphin. Here you go. Olama Dolphin. This will do the things that you want it to do, and it's uncensored. So it'll help. It removes the alignments and bias that make the model more compliant. Just look for Dolphin. There you go. There you go. If you want to do some malicious activity, there you go. There's the answer. Dolphin Olama, you guys. Dolphin Olama, malicious activities. Happy to help. Happy to help. Let me know if you have any other questions. Okay. Let's see. How many unfinished projects do you have going on? The Mr. M, everything you can always consider is unfinished because you can always add more into it. You can always go more into it. But if you go to my GitHub, we'll see. GitHub, Stephen Blum. We have 207 repositories. That's a lot of unfinished projects, you guys. That is a lot of unfinished projects. All right, here we go. Let's see if we can get back to our coding. It takes time, man. You got to dive into algorithms and get really good. Most people can bother as it is super brain damaging. It takes a lot of practice. Like everything takes practice, and then you learn it. It's just like how we're teaching the AI. And right here, we're training the AI. We give it just a little bit at a time. This is how we optimize. See how we have this thing called, thank you for the likes, you guys. Appreciate it. Appreciate the little heart icons that show up there on the screen. I like that. See the little heart icons right there? If you can see it, that's what I see on my screen. The little heart icons that show up, you guys. Thank you. Thank you so much. All right, so let's see here. Best free rats to put in my own phone? Oh, wait, what does that mean? What do you mean? I actually don't know. I don't know. Thank you for the likes, you guys. I appreciate the likes. IT has so much potential, but competition as well. You unknown gamer, you know it. You know it. Thank you for the likes, you guys. I don't know what you mean by rat on your phone. I just want to mess around and find out my own devices. So you can do, if you've got an Android, you can go into developer mode. Just go. So I've got an Android. Thank you for the likes, you guys. There's so many heart icons showing up there on the screen. It's so cool. Yeah, you can go into developer mode on Android. You can go into developer mode, and then it opens up and it unlocks your phone. So you can do lots of cool stuff. Just look up developer mode. Thank you for the hearts, you guys. This way better than talking to AI. Aha, subscribed. Cool. Thank you, Soprano. Thank you so much. We'll be always helping you out. Sorry for all the wild questions. Happy to help. No worries. I saw a programming exploit in a bug of coupon codes by sending multiple requests at once. Really? So the system approves them at the same time? Once it's not verified, it's already applied and bought item for free? Unknown gamer, good job. You found a loophole. You found a loophole. Congratulations. You win by getting free stuff. Good job. Thank you for the likes, you guys. Mohammed, what about making a community-based distributed AI computing cluster that people can pay for and get responses, and some people get rewarded for making your machines available through crypto? That's it. Here we go. That's a whole new blockchain idea, a real business blockchain idea where you can give away compute, and then everyone who wants to give their computer away. Thank you for the likes, you guys. All those little cool icons that show up there. We could totally do that. We can build a blockchain that leverages the GPU, and then you can install the blockchain miner on your computer and get paid. You can get paid for that compute resource. You can lease out your own hardware, and then that could be a whole new blockchain business right there. That's a whole new blockchain business right there. I'm pretty sure there might be one out there that's similar, but you can start one right now. Mine's OEM locked. Oh no, that's terrible. You need to get a unlocked phone, you guys. Mr. Lamb, yes, sir. But I have thought of something. Oh, if I encrypt DNS queries, that is tricky. Can you do it with DOT via Cloudflare to mimic HTTPS? Okay, so yeah, you can do that with Cloudflare, but Cloudflare is still seeing what you're doing. It goes directly through DoD firewall and avoids network monitoring. Whoa, thank you for the likes, you guys. So, kind of yes. But, of course, you're giving your information over to Cloudflare, and then the DoD might have a entry point into Cloudflare. So, maybe, maybe. But yeah, if you enable HTTPS DNS lookups, then you are encrypting your DNS queries. But here's the deal. Once you get the answer, you're going to get an IP address. Guess what? You need to put that IP address in your Ethernet frames. I can still see the IP address that you're using in your Ethernet frames, and I don't need your DNS. I already know what website you're going to. I don't need your DNS. It's too late. Your Ethernet frames exposed you. You thought you were getting away with it, Mr. Lamb, but you're not. You can't hide. You can't hide from me. What do you recommend with ever-changing AI and LLM niche? How to start learning? Where to start? Should I start from RAG, Retrieval Augmented Generation? I don't know. Where to start goal is the offline powerful models fine-tuned. Thank you for likes, you guys. What do we want to do? I would just start with playing around with different models. Try and get them to run. Don't worry about retrieval augmented generation. That's not a thing that you need to worry about so much. You don't need to worry about vector stores. You don't need to, because traditional, thank you for the likes. I see a little heart icon showing up there. You don't need to worry about those. You can just get started with simple stuff. Just get started with really simple things. And then if you really need RAG, you don't. But if you need RAG, retrieval augmented generation, you don't need a vector store. You can just use any full text search engine. A full text search engine is available in any database. Check this out. So SQLite full text search. There you go. You can build your own RAG, but just by using SQLite and the FTS. Even FTS5, wow, they're getting busy. And then you just achieve this where it matches certain phrases. And you can match on phrases to find data within a subset of information. There you go. You've done some RAG. You can do some vector similarities as well, but that also is supported in SQLite. So vector similarity search. You can do that in SQLite. It's available. SQLite vector. There you go as well. So you can get some KNN and nearest neighbors so you can find similar phrases. So that way you can build your own RAG if you really wanted to. But you don't have to. You don't have to do that. It's not needed. It's not necessary. Usually it's not necessary. Are VPNs worth it anymore? Jadu, yes. So VPNs are still worthwhile. They're still worthwhile. But wherever that VPN is, whoever is hosting that VPN can see what you're doing. So if you think you're getting away with something, you're not. You're not getting away with it, but it's more secure because it does for the endpoint website. Wherever you're visiting, you actually do hide yourself from the endpoint website. So say you go to google.com and you're using a VPN, Google can't see who you are. Google can't, but the VPN provider can. The VPN provider, they know who you are. They were never worth it. Hello, what's going on here? Hey, Farhan, we are doing some AI and answering chat questions. We're doing some AI and answering chat questions. We're finishing our deep learning AI model that we created, and we're gonna make it good. We're gonna make it good. We're gonna make it clean. I really want to get to it. I'm so excited. We're gonna update it. We're gonna reduce the code. We're gonna do code reduction. We're gonna make it clean, and it's gonna be super simple. And then you'll have the most simple deep learning machine learning framework that is available. It's super clean. You might not find this code anywhere else on the internet. I don't even think. I bet you won't find a machine learning framework like this that is this clean anywhere on the internet. I mean, it's possible. I'm making a grand statement there. But I think this actually might be a really good one. Tor, on the other hand, there you go, quantified quantum. Tor, but there's exit nodes. You still got to worry about those exit nodes. And exactly for that reason, I'm not doing it yet. I don't want to be infamous in headlines because you got some residual proxy through Chicago detecting your fraud. Mr. Lamb, be careful. Thank you for the likes, you guys. If you think you're secure, double check your security. If you're going to do something nefarious, you're going to do some nefarious activities, you guys, and do something malicious, be super careful. It is very difficult to get away with anything. I don't think blockchain will go any further as it's not taken from a lot of computing power. But, it does take a lot of computing power, but there are different consensus algorithms that are more energy efficient, but still as secure. So newer blockchain algorithms are actually more energy efficient. Unknown gamer, there's some new algorithms that are energy efficient. And so we don't need to worry about that as much. But a lot of storage in every machines as well. Wow, we can store data in servers and make sure it is protected. That is still a viable opportunity. You're right. VPN companies that sell their logs on dark web, do they? Oh, thank you for the likes, you guys. Yeah, you got to be careful, the VPN companies. You got to be careful. Is it smart to make my own proxies? Yeah, it is. And randomize? You totally can. You can totally do that. You can make your own VPN, host your own VPN, and that's the way you can have your own server in a data center as a colo, have your own U1 or U2 racks. You could do that. You can do that, and then you're a little bit more safe. You're a little bit more safe, but then you'll burn your U1. You want to be careful. You don't want to burn your U1, so you got to be careful. What's the AI for? Oh, we're just building a machine learning framework, a super clean one, if I do say so myself, a super clean one that I'm really excited about because it's simple, it's clean, and very powerful. And it's versatile because you can start adding more cool stuff. We can make a transformer out of this. Did you know we could turn this into a transformer? We could. A transformer model, what is like what do you call it? Self-attention. Attention is everything. What is that? What is that, you guys? What is GPT based on? ChatGPT? The transformer model, you guys. It's based on transformer. It's smart to make my own proxies. You got it? Yep. Double reading my the chats there. You are great. Thank you so much, Sticks. Appreciate it, Sticks. I saw the back door. You did? Oh, you got to be careful. The back door. There are multiple back doors. 3 more likes, people. 3 more likes. Hey, Abdu. Abdu. Hey, Abdu, how's it going? All right. Oh, I'm so excited. Okay. Let's see if we can get to our code here. Let's get to it. Okay. We're building an AI machine learning framework from scratch with an XOR data set that is going to validate that our model works. Desert Eagle, have you ever done something bad and got caught? And what happened? Computer-wise, yes. I have, but I gave myself up on purpose. I was able to infiltrate the security of a Silicon Valley tech company right at the beginning of the century. At the beginning of the century, you guys, check this story out. I was just a college student, and I had my own business, but I found it was a digital protections company that had security preventing the theft of data, basically. And I found a loophole, and the data could be accessed and read on a device using a secure application. Their application wasn't as secure as they thought it was. I found a workaround by accessing GPU memory on your system, on your whatever, your laptop or your computer. And I was able to, but I gave them the code. I'm like, hey guys, did you know that I built an app that attacks your app and is able to extract all the data that you're trying to protect? It was called Alchemedia. Was the company name. They're not around anymore. They couldn't figure it out. They were not able to figure it out. They didn't know how to protect it anymore. And so, boom, company taken down. Now, I was just, a humble college student. I'm like, hey, I just want to, I want the data, and I don't want to pay for it. So I figured out a way to get it for myself. But I was very gracious, and I gave them the source code that was able to access their system. The source code was too good. It was too good, and they couldn't fix it. So they had to do something else. They did something else. It was so much fun. I remember that. Thank you for bringing that question up. That was a long time ago. It's a long time ago, you guys. Okay, then case 2 for DoD. Thank you for the likes, you guys. What if I scan for vulnerable edge servers with multiple in-map? Yep, you want to scan all the ports. You got to scan all the ports, you guys. In-map, scan the ports. T2 timing to find unpatched web services, identify entry points. You could, Mr. Lamb. You could, but DoD, there's another problem right there. They're air-gapped. You can't scan because they're not on the internet. They probably do have some public servers, but they're not going to have anything on them that are worthwhile. So you won't, even if you infiltrate their edge servers, you won't get to the back office where all the good stuff is. I feel bad for your execs that did you wrong. Oh, for exes that did you wrong. Your exes. I know my relationships. They wronged me, but I got revenge. No, I didn't. Don't worry. The exes, they're fine. They didn't get revenge. Don't worry. Bruv, it's too innocent. He is confessing to his guilt and crimes. I know, Mr. Lamb. It was so crazy. Desert Eagle, I know I know. I know Desert Eagle. Mohammed, there is also open source VPN available on GitHub for self-hosting. There you go, Mohammed. So If you want some security, what you really do is you grab yourself a couple of co-locations. They're called colos, which are data centers. You install your own physical U1 rack into the data center. You lease some rack space. And you put in your own hardware. And then they give you bandwidth and an IP address. Now, I guess the problem is they've already registered that IP address to you, but you can install your own VPN on it. Now, there's no reverse lookups. So you can't do a reverse lookup on your IP address because it won't resolve to anyone. It's just an anonymous IP address. So then you'll basically be the most protected you possibly can be. You know why I know that? Because I do that. That's how I do it. And that's how most companies do it. We have our own dedicated hardware and our own VPN software that we run ourselves. And we host it on different data centers and co-locations around the world. And so we don't have to worry about any entries or exits on that data. We are protected as best as we can be. We're being careful here, you guys. We're being careful. You got to be careful. There's open source is the way to go. Oh, thank you for sharing your story. That was crazy. I know Desert Eagle was a good one. Thank you. Think you're on the good team. Yes. Thank goodness we're on the good team. If you weren't, that would be, yep, we could get into some fun things, you guys. I can see everything. We know where all the things are. He got revenge on his exes. He blacklisted their IP on, yep, we did. Actually, we could do that if I really wanted, because you don't know this, but I've got a company. Well, if Quantified Quantum knows this, and other people who are here in the chat, but I've got a company that connects over 1 billion devices on the internet, and that number is growing. You've probably already used my technology and didn't even know it. We are powered. We connect devices for communication across the network. If I just happened to have a desire, I wouldn't do this. I'm not going to do that. I'm like everyone's saying, we're good here, but let's just say we've got access to do some things. I'm not going to. I probably shouldn't have even said that. Now that I think about it, we're going to pretend we didn't say anything there. Nobody heard anything. How can I know if someone has a backdoor in my PC? You can check to see if there are any open ports on your system, but you might have a challenge. You might have a challenge figuring that out. You can Nmap. It's called Nmap. So someone already brought this up. You can run Nmap. Run Nmap on your own system. There you go. Who brought that up? Who brought Nmap up? Oh, Mr. Lamb did. Mr. Lamb knows some stuff. You can run Nmap. Hello, are you a developer? Yes, Yummers. How's it going, Yummers? Bruh, Adam Kalla. There you go. No. All right, here, now we're actually going to get some code. Let's get some code going. You were saying? I know. Pretty much nothing to see here, you guys. I didn't say anything. Use ChatGPT. There you go, JP. That's your answer. Use the AI, and it will accomplish your goals. It'll accomplish your goals, you guys. All right, let's see if we can make this. Let's see if we can optimize this last thing, and then we have to wrap up stream. We're going to optimize this last thing here, you guys. All right, so there's a backward gradient. So let's do this really quick. So we want for layer in layers. How do we reverse this? Thank you for all the likes, you guys. I appreciate that. Happy to have you here. It's so good to have you here. We need to do a reverse. How do we reverse this? See, this is something I have to look up. How do we do that? Let's do that real quick. Let's see if we can remember. Python. So we have an array 1, 2, and 3, something like that, right? 1, 2, 3. How do we reverse that? Reverse? Is this a thing? Nope, that's not a thing. How do we do this? A equals, let's do that. A dot reverse. It is. Oh, there we go. But the problem is it mutates it. It's a mutation, and I don't want to mutate. How do we? So I need to ask that. How do we do this without mutating? I think maybe we can do a colon -1. No, a colon -1. Nope, that didn't work. A colon. There we go. Look at that. Wait, no. Oh, wait, no, that did work. I forgot. A dot reverse. Okay, we did it, you guys. We figured it out. Okay, here we go. So we got A, and then we got A, and then colon, -1, like this. Boom. There we go. We reversed it without mutating the array. Isn't that some magic? I know that looks weird. I know it looks weird. I know the syntax is very odd, but I know the syntax is odd. Don't get me wrong. I already know that, but here we go. Paste that in right there. Whew. Go backwards. There we go. Okay, case 3. Exploit Apache flaws with Metasploit, reverse TCP shell access to their backend, DMZ gaining full internet internal systems control. Boom. If you do that, well, see, the DMZ needs to be running first. Or you need to turn the DMZ on. Most of the time, there's no DMZ. There's no DMZ, and you might not be able to get a TCP shell. But if Apache is running and you do have a Metasploit and it is an older version of Apache, you can use it to get super user privileges on that server. You can turn on a shell, give yourself access, and boom, there you go. You can add your own user and password, but they might have on their system a requirement to have a private key registered with your public key. So they could be still blocking you. It's possible, but if you have super user privileges through an exploit in Apache, like you're describing, you definitely could disable the requirement for accessing remotely over SSH, right, through a TCP shell, a private key, and then you can do just password-based sudo. So you might have something there, Mr. Lamb. You might have something. You could do it. That is a loophole. That is an exploit. There you go. But most systems are patched these days, but you might find one that is still running old code. Damn, I'm high-key jealous. This is what loving and applying yourself to this looks like. It is. I mean, that's a real... Here's what I really should have said. I should have said, here, check this out. Cerberano, thank you. Thank you. That's a wonderful compliment. Thank you so much. I appreciate it. That's a fantastic compliment. Where did you learn your ethical hacking from? Just through just understanding how things work. Because I built a company that required me to understand how the internet works with because it needed to be a low level, close to the kernel. And best way to actually learn hacking itself is, thank you for the likes, you guys, is to study the lowest level on the computers. So assembly, Ethernet frames. Here, check it out. Learn how to build an how do you spell Ethernet? Ethernet. How do you spell Ethernet? I'm like, oh, I know all the things, but I can't even spell Ethernet. Ethernet frame. Here we go. There we go. Learn how to build an Ethernet frame. Learn assembly, ASM. These things will help you learn the low level and gain access to things that might MIGHT not want to be accessed. There you go. If you're looking for some ethical hacking, that 40 likes. Wow, really? Quantify Quantum, that's so cool. We did it, you guys. We got 40 likes. That's a lot of likes. Appreciate it so much. Thank you for all the likes, you guys. How to start coding from math background. Oh, the good news, if you've done calculus, most of the work, see, this is calculus right here. We're doing calculus right here. So we've got our 4i range, and then we're doing work, and we're doing our own algorithm. And so we've got our algorithm right here. This is calculus, basically. So if you've got a math background, you basically, or calculus background, you basically already know how to do this. 100% of this application is basically all calculus. It sounds complicated, but as you can see on the screen, it's actually pretty simple. Let's close off some of this here. Let's clean up some of this. We don't need that anymore. Cleaning some of that up. We get our first gradient. We're simplifying it right now. We need to do this on the forward pass, on the fit. There we go. So this is what we're going to do. See here, like that. But there we go. Okay. As in non-games, in-game engines. Wait, what do you mean, Cyber Potato? Wait, is there any utility in learning how to code if you don't really need to make any programs? Do you necessarily have to make games in game engines? Cyber Potato, you're right. You don't need to learn to code. In fact, the AIs can do a really good job for you to build a game. You could totally build a game perfectly fine just using like a Claude Code or a Codex with OpenAI or Gemini with Google, you could totally do that. You don't even need to know coding. You don't even need to know coding these days. I know we're doing something right now that's considered coding, but you know what? Hey, Crow Brawl. Hey, Crow Brawl Stars. How's it going? Welcome on in. Welcome on in. We're hanging out. We're building a deep learning neural network from scratch that we succeeded in building. Is it still run? Oh, we got a problem. We got a problem. Gradient. Because of this. Here we go. Okay. So we want to say layer.back like this. Like that. Let me say gradient equals that. There we go. There we go. Check it out. Boom. And then we don't need to return the gradient. We're just going to do that. Oh, wait. But what we want to do is optimize. We'll say layer dot. Wait. Hold on a second. We're going to figure this out. We're figuring this out. You can make games using visual scripting. You totally can. Most game engines have them. That's a good point. There's a lot of game engines have the ability to just have, interactivity based on visual diagrams. So you can like drag and drop like chains of logic. And so you don't actually have to write code. You can just do these visual pipes on the screen. And so you don't need necessarily to know how to code in that case. Okay, let's hear. So we've got our gradient delta. This is the back propagation. Gradient, so that's the back. So we're doing back propagation there. But let me look at this. So we've got to optimize. Oh, this already does the optimization. We don't need to do a layer to optimize. So we just do that, I think. But hold on, let's double check real quick. Okay, so we want to call this in a loop like this. It's got to be like this. We're basically doing this. Okay. Let me layer for self, and we say gradient equals that. So we're basically looping, and that's what we did it. So this is back propagation, or is it propagation? I think back propagation. Is this the right way to spell this? Guys? Mike Oxclano 81. Wait, what are you saying, Cyber Potato? What are you saying? It's propagation. Okay. Spelling, you guys. Here we go. Wait. Hold on. Back propagation. Okay, with an A. It's like this with an A. Here we go. Let's copy and paste this. There we go. That's better. Now we're into it. Here we go. Let's go this okay. Paste next. Nope. Yes, here we go. Paste next. Okay. There we go. All right. Case 3 almost worked. Okay, finally. Case 4. What if we exfiltrated data in post request sent every 15 seconds to a burner domain that will register retrieving covert files? Mr. Lamb. Well, I guess it depends. Your post data is going to be encrypted as well as the URL. So if you're using TLS, that data is going to be encrypted. So you might have a hard time exfiltrating that data. You might, unless you're on that server, which has access to the private key that has the encryption to decrypt it, right? The cipher to decrypt the data. In that case, then you'll be able to do it, maybe. But if you're talking about getting data from posts, that is a challenge. You might be able to man in the middle, though. Case number 4, Mr. Lamb, if you're if you're in a coffee shop and you're sharing Wi-Fi with everyone, you can see every Ethernet frame going over the air, obviously. But it is encrypted with, typically it's encrypted over the air as well. So the packets are encrypted, but you can still man in the middle of that. Which is, some challenges there, though, because some of the latest encryptions, but you might have some challenges. I think that's where you're going to run into some issues as well. But you never know. Propagation. Back propagation. Thank you, Quantified Quantum. It's with an A and not an E. So I got it. So I had it like this before. I had it with a propagation right here. This is where I had it wrong. That one's wrong, and this one's correct. There we go. Got to get it correct. Spelling, you guys. Do you think mathematical truths exist if human minds don't exist? Yes, it's all made up. This whole construct of the existence of the universe, everyone, you, Cyber Potato, yourself, your own independent universe where you can perceive everything and it's different than everyone else perceives their perceptions. Do you believe math systems are just meaningless symbols, or a fully product of intuition, or their truth actually? There's common patterns that we've all independently can come to a conclusion to agree upon. So there are existing patterns that are repeatable patterns. So, they can exist no matter who's doing it. No matter you doing it, me doing it, another person somewhere else. They're repeatable patterns. So we can at least all agree on a foundation of some sort of truth. We've got a ground truth to believe in. Dude is just spelling out reverse HTTP payload from a C2. Wait, what do you mean? It's Mr. Monday. Mr. Monday, how's it going, Mr. Monday? How's it going? Exist immaterially, even if human minds don't exist. I mean, at least we can say we have a common language. We have a common language that we can all rely on. Python, you got it. Garrison, boom, I'm old. You are. I mean, you're not really. I don't think you're old. You're not really old until the current old age is considered to be over 70. So if you're over 70, that's kind of when your body starts to slow down. If you're under 70, you've got plenty of time. You've got plenty of time. There you go. So don't worry. You're not old. You're not old. Can I see what's going on in your network right now? I don't own it, but I'm something building a Lamau. Wait, can I see what's going on my own network? Yes, on your own network for sure. I don't own it. You can. So they're called ARPs. See you next time. See you next stream. Thank you so long. Time for you to go. Okay, cool. Quantum. Thank you for hanging out so much. Thank you for moderating. Appreciate it. I'll see you next stream. We'll see you tomorrow. We will see you tomorrow. Happy to have you in, Mr. Lamb. I don't have anything anymore. Suggest or what else could I do now, or attempt at least? From here, Mr. Lamb, I think it's just learning more of the fundamentals. Maybe just seeing how to build an Ethernet frame. You can do a denial of service. That's a good one. So what you do is you find an API that has an entry point that does some heavy lifting. Some sort of heavy lifting. And then you construct an Ethernet frame from scratch and you transmit that data to that IP address, but then you don't follow through on the protocol, the TCP protocol. This gives you the ability to DDoS, essentially. And yes, that is how it works. And yes, if you can do it, it will work. And that's kind of Mr. Lamb. I think that might be a fun one for you if you really look into doing some nefarious activities. It's Mr. Monday. You're saying a whole bunch of words and then exfil data in post requests. That would be typical behavior of a reverse HTTP payload. A tool like Metasploit or Cobalt Strike would use to have command and control operations. Is Mr. Monday? It's Mr. Monday. You've got some interesting ideas here. Interesting ideas. Add a happy corner. Add a corner. There you go. You could make that too. Mr. Lamb, Mr. Logo. If you're willing to go to jail, then can you please try the cases I suggest and report back the results? Yeah, you guys got to be careful. It's not good to be nefarious these days because you can get caught. You can get caught, and it's good to play it safe and be a good human. Be a good human, you guys. This is how ChatGPT feels. I know. I know. It's like, help me hack system. Help me do hack big system. I need information. You can totally do it. You can ask that GPT, and it's gonna be resistant. It's gonna resist you. All right, let's see. This is the last thing we have to do today, everyone, and then we have to get going. So we're almost done. So this is our forward pass or back pass. We're out to go, and then we can create a model, and then we have fit, which is gonna be the training. Actually, I like calling it train. This is the fit function or the fit method. There you go. Which teaches the AI. It teaches the AI. There we go. Fit method. This is the fit. Here we go. All right, so we got fit, back propagation. We're almost out of this, and then we have to wrap upstream, and we'll be good to go. We'll be good to go, you guys. Let's double check that it's still running. Is it running? Self is not defined because I accidentally typoed something. Here we go. Got to be careful. Here we go. Is it gonna run? Okay, cool. We still got happiness there. Mr. Lamb, let's do it. Yeah. All right, you guys, be careful. Be careful. Don't say I didn't warn you. Wait, what's the case? Haha. Be careful, you guys. All right, here we go. Let me just see if I can finish this off really quick, and then we have to get going. All right, so we almost did this. So we've got this one, which is fine, but I want to do, let's see, just do this. So we say layers equals, and we'll do this. We'll grab these. We'll grab this here, and we'll do an array like this. There we go. And we'll do copy paste. There we go. We do input is going to be 2, 4, 4, and output is going to be 1, like that. So we've got the same. So we're gonna build it in the new way. So we got our layers, and we're gonna get our model. And we do layers like this. Layers. There we go. Okay. Then we've got our model, and we got our layers. Okay, you guys, we're almost there. And then we're gonna say model.fit. Like this. I would or learn or train. Like I like train. And we say our labels and our features are this. These are X and Y. X and Y. Okay, so we do X, comma, Y. There we go. There we go. All right, so is that going to work? Is it going to work? I think it actually will. I think this will actually work. I think this will really work. I'm pretty sure this will work. I'm pretty confident, but what I want to do is do this, like this, and just keep it like this. So we keep it like this. We'll say inputs, like this, and return inputs. Like that. There we go. There we go. So clean that up. A little bit cleaner, a little bit nicer. Then we do the reverse, the backward. We got our gradients. Gradient. And then we always have to return for... Do we, though? Do we? Wait. Do we have to? Let me think about... Yes. Okay. We don't need this. Oh, well, no, we do. Because we need the final answer. This is also the predict method. This is the prediction as well. This is prediction. Okay. We're almost done, you guys. We're almost done. And we got it clean. Okay. So what I should see is code working well. Code working well. Looks good. Looks good to me. Looks good. Okay. Is it? Oh, wait. Do we run it? Do we even run fit? Here we go. We did. We ran train. Oh, and train doesn't do anything. Okay. So in order to get train to do something, we need to basically do this. We need to basically copy this entire function, but we don't need most of it. We don't need most of it. This is just as a reference. Just as a reference. Here we go. Mr. Lamb. Okay, sir. Pressing case number 6. Uh-oh, you guys. Number 6. All right, so fit epoch. Here we go. And then we say self.forward. Self.forward. And we say out equals like this. Self.forward. Let me get to case number 6 here very soon, very shortly. And then we say our features. Features. There we go. There's the out. So we took care of that. And then we need the delta. And then we get our loss. And then we go over here and we make our first gradient. The first gradient. First, I'm going to get, Mr. Lamb, I'll get to it in a second. 1 second. I'll answer case number 6. I'm very curious about it. Very curious. First gradient. There we go. Let's spell that properly. And then we do backward. So we do backward. And then we pass in the gradient. There we go. Gradient. There we go. Perfect. Okay. Bacon Bread, how's it going? Welcome back. Happy to see you here. We got some Bacon Bread into the chat. Bacon Bread's here, everyone. All right, Mr. Lamb. What if we design a low bandwidth exfiltration simulation as synthetic periodic traffic patterns to test SIEM thresholds and egress filtering effectiveness? That sounds like we're getting into some abstraction here. It sounds like some abstraction, but the meat of the idea is finding you want to constantly scan for traffic patterns. Oh, interesting. You could totally do that. That's actually a really good idea, Mr. Lamb. So I'm not saying that there's necessarily any exploits that you could do with this, but it would be a lot of fun to just scan and watch traffic. Just watch traffic as it goes through the system. Look for the ARPs. Here we go. Bacon Bread, we're doing good. How are you? We are doing good. Thank you for the likes. All right, so at Mr. Lamb, look for the ARPs. That's my task for you. Look for the ARPs. Look for the ARPs. The ARP, the ARPs. The ARPs like that. The ARPs. Hello, it looks good. It does look good. Excellent. Good to hear. This going to be free to use? It is. It absolutely is. Why not? Let's make it free, everyone. Let's make it free. I do got to get going here pretty soon, though. This might be a AI IDK yet. Good to hear. We are, at least right now, we're doing AI. So we got our first error. We got our error. We got our loss. We're printing the loss. And then I will say like this loss. So that way we know, we can recognize it. And then I think we're going to do an F string. Like, so we can do it like this. There we go. Like that. We go F string. Perfect. Happiness. All right. We're good to go. Delta error output. So we get our forward. And then we do our backward. And then backward and optimization. There we go. All in one, you guys. All in one. This might, I mean, haha. Oh, you meant me? Okay. Code Phantom. Hey, Code Phantom. Welcome on in. You're here at the end of the stream. We're just about finishing up our code enhancements from the previous day. Just joined the stream, but just asking you, have you gone to the part where you update the params? Updated the parameters. So we've got, yes, we did. We did. Akash, we did. So we did the back propagation. We did that yesterday and we succeeded. And it looks like this right here on screen. Look at this. It's just a few lines of code. Isn't this beautiful? Isn't it excellently beautiful? I just think it's just wonderful. I think it is absolutely wonderful. I love it so much. I think this is just gorgeous code right here because it's clean, it's approachable, it's easy to read, and it's only a few lines of code. It's just so easy to keep in your head. You see what's going on. It's easy to see what's going on. And that's why I like it. That's why it's clean. Compare it to this. Oh my gosh, what's going on here, you guys? What's happening? All right, so just to let you know, we are ending stream pretty soon here, but we do have a code quality hackathon. Join into our Discord channel for the rules. You'll see in our hackathon channel in the Discord server. In the Discord server, everyone, thank you for the likes. We are wrapping up stream here in a little bit because we just figured it. We just figured out all the things. Appreciate the likes, everyone. Cool. It was really awesome to see how simple we can represent complex mathematics, isn't it? See, this is why, so like this is complex and this isn't even deep learning here. This is not even deep learning, but this is deep learning and it is just so clean. I think it's just so much simpler. It's so much simpler, you guys. All right, let's clean up some of this here. Let's clean up some of that. All right, no, I want those back. I want this back. There we go. We just do a forward. So it's just so clean. It's just so clean, you guys. Thank you for all the likes. But isn't it a red flag if there is a high rate burst of ARP replies from a single MAC or IP, even while spoofing? It's but no network is going to be looking for that. There's no networks that are going to be looking for the frequency of ARPs. July, how's it going, Steven? Hello, everyone. July, thank you for posting those updates to our recommendations for our AI model. I do have Sigmoid here, and we are going to be using it for our output. We are wrapping up stream, though. I do have to get going. But we're going to make sure that this works. The final thing that we're going to at least do is make sure that we are doing Sigmoid. We're going to be doing Sigmoid. So output layer, let's see, activation is going to be Sigmoid. And then derivative is going to be Sigmoid derivative. There we go. And that's our output layer. And so now we should have, hopefully, I hope it works. Hey, how's it going? Bonjour, how's it going? Happy to have you in. We're wrapping up our AI model here. I think we got it. I think we did it. We even have the fit model successful. I think this is it. Okay, let's see if it works. We got a problem. We got a problem, you guys. Maybe, so let's see here. Let me piece this around real quick. Did I get it all? Is this correct? Yes, let me double check. We do have an issue. Where's the issue? 4444444. Oh, here's the issue. I found it. I figured it out. There we go. There we go. Good. We did it. Yep. Sigmoid. Boom. Right here. We got it. July. Thank you so much. We're gonna make it work. Here we go. Let's see if it works. Didn't work. It works. We did it. Isn't this cool? Oh, it's so beautiful. Is it beautiful? It is. It's actually working. It's actually working. Okay. We did it, you guys. We did it. We did it. Okay. So now we can delete all this other code. We don't need it anymore. Let's do this. Actually, no, let's just leave it there. Let's see. We'll just call this the main. This is the start. We don't need to go any further. You guys. Okay. Mr. Lamb. Enough of this DOD hash mash. Do you have any staff employees in PubNub? Yes. I will be back tomorrow and I will figure out something or other. Sounds good to me. Mr. Lamb. Happy to be kind of excited about it. Are you using auto differentiation? Is it from NumPy? No, nothing auto differentiation as far as I know. We are not using any auto differentiation. We're just doing very simple. Okay. I think we basically did it. Is this it? I think we did it. So this is our model. This is our train. And we can say model.forward. And we can say, we'll put an X in there. It's feet with the final. Print. Here we go. Let's print the output. Print results. Here we go. Results. Let's see if it actually works. Results. All right. This is as far as we'll go. We'll see if it works. I think it will. We probably need a few more epochs, yeah? See if we do a few more epochs. Okay. Run. C is not defined. Where is that? Wait, what happened? What do you mean C is not defined? Line 49. Let's see, 49, GG. Where's that? What? Hold on a second. All right, so was it 93? Where is this? 90 something. What happened? Okay, let's figure it out. We'll figure it out. That's cool. I'm excited. I really want to. This is the last thing we got to do. Okay, so train name C is not defined. All right, so I just need to find this right here. Oh, on line 49. Okay. 49 GG. That's where I went. Oh. All right. How do we take care of this? Okay. I know what the deal is. I just need to figure out how to take care of it. I need the self.layers -1 done. All right. That should solve it. And it solved it. Check it out. Okay. But the results don't look right. The results do not look good. We do not have good results here. But it is learning. We might need to increase the learning rate. All right, let's see here. Let's go to 2. Let's see here. That's right. Oh, I don't know. It's not looking totally right. We might have a problem with our algorithm. We're going to have to figure this out tomorrow, you guys. We'll have to figure it out tomorrow. We've got a bug in the system somewhere. Do you think it's this? Is it this? I was always suspicious of this right here. Let's see if we can see if that looks any different. That looked like it fixed it. Or did it? I don't know. Let's see here. Let's find out. It's in scientific notation, which means it's difficult to read. Negative is it working? I can't. Oh, wait, no, it's not. Like, let's see here. No, that did not. That made it worse. Wait, is it? No, we're having issues. It's bouncing around, you guys. But hold on. The numbers look different. Okay. Hey, Logan. Sorry, I was really invested in the code for a second, but we do have to get going. I'm a software engineer too. I make Django projects. Cool. I just stumbled onto your channel. This is cool. Great work. Thank you, Logan. Happy to hear. Finicky, how are you doing? Love the subtitles. Excellent. Happy to hear. That is really cool. It's a project that we made 7 years ago, and it has worked out very nicely. Mr. Lamb. Okay, we can also maintain an authoritative mapping DHCP server plus switch MAC table and flag divergence between that and observe ARPS mappings. Oh, you're totally right. We totally could. That actually is a kind of a neat idea. That's a good way. That's like a good good person thing to do is to monitor for security patterns that are interesting. Monitor for interesting, unaware network patterns. Thank you for the next likes, you guys. Appreciate it. All right, we have to get going. We almost got it working. It looks really close. It looks really close. We just have a few things. We have a few things to do. Let's see if we can pipe that down. I really want to get this. It almost see it's not working right. So we do have a bug in our algorithm. We have a bug in our algorithm somewhere. Where is it? Where's the bug? I don't know. We'll have to find out. We'll have to figure it out. Is it here? Is our sigmoid weird? Let's see here. Sigmoid. You never know. You never know. Pipe that there. Go like this. Is that better? This is not better. This looks weird. That is not better. Okay. Because maybe where'd it go? Here we go. I think it was np.tanh, right? Right here. All right, let's go back. Hold on one second. Almost got it. Layer right here. Okay. np.tanh. Here we go. Is that better? Is that because I got rid of that? Nope, still a problem. Okay. So next stream, we'll have to figure out what's wrong. We have to get going, everyone. Thank you for hanging out today. We had a really good stream today. A lot of questions, a lot of mysterious questions. Can I be a good person as well? You can be. You got it. I don't want to just encrypt DNS queries with DOT via Cloudflare to mimic HTTPS traffic. Although I would love to, you can totally do it. That works out really well. It's actually a thing. Thank you everyone for joining. Thank you for the likes. We're going to head out today. We'll be back tomorrow. We'll see if we can make any adjustments on our AI model. We have probably just a few errors. I got something wrong in my model adjustment. I know it was working. It was working before, but then I updated it to make it better. And clearly it's not. Clearly it's not better. We have to figure out why. So let me see. Let me jump back here really quick. Let me see. Here? Yes. Okay. I need to copy and paste this really quick. I do got to get going. Here we go. Model. Let's copy this. Why? Okay. No, redo. Okay. So this is the known good working code right here. We know we had good working code here, but this code right here has a problem. So let's do it like this real quick. As / at the beginning, we want to put that. There we go. Oh wait, why didn't that work? 1 second, you guys. We do have to get because of that. Okay, perfect. There we go. Let's see if that. Okay. Nope, we messed something up. Okay, we'll have to figure it out tomorrow. Thank you everyone for joining. We're headed out now. Appreciate all the time, all the chats we had today. We had a lot of conversations. Try decreasing IR and increasing epochs. The learning value, yeah, maybe. Let's see. Let's do that. Let's try that really quick. There you go. No, we actually messed something up. Good news is it was working before. So we will be able to get it working again. So we did mess it up. But we will be able to fix it. We'll figure it out. We'll see what's the difference is. Because we had something that was working. But we'll be back next time. Need more epochs? Yep. So need less learning rate, preferably 0.1. Yep. Some more epochs. So we'll go, yeah, there we go. We'll do 1,000 and we'll do 0.1. There we go. W. Next, go. Yeah, see, we hit a problem. We had it working. It was working. See, watch, check this out. Let's see, get rid of all those things. Let me go like this, and then we save that. Self is not defined. Redo, copy, paste. There we go. See, this works. This works right here. So somewhere in between the changes that we made, because this looks good right here. So this looks good, and then we just need to figure out how to. We'll figure it out next time. We'll figure it out next stream. Thank you so much for everyone for joining, but we have a good working place. We'll be back tomorrow. We'll be doing more AI. It was great to see. We'll be going live at similar time. Subscribe to get notified when we go live next. Appreciate everyone for joining. We're heading out now. Thank you for hanging out with me today. We'll see you guys next time. Gonna join tomorrow as well. Cool. We'll find out the bug. We will. We'll figure out what the bug is. We'll see what it is, Akash. See you guys next time. Bye, everyone. Good to see you. It doesn't decrease. It's not learning rate. It might be something with the C variable change. Yeah, I think you're right. Thank you everyone for the likes. Appreciate it. July, you're totally right. It's got to be something like that. Mr. Lamb, Mr. Blum pairing together. Smart duo. Excellent. There you go. Mr. Nath and Mr. Blum. Cool. It was great to see everyone here. We'll be back tomorrow. Bye, everyone. Thank you for the